Okay.
So I'm looking at 1, 2, 3, 4 classes. Textbook says, generally speaking, what's the minimum number of classes? What's the textbook number? Anybody? It's in my packet too.
Wasn't it at 5 to 20?
It's exactly right. Okay, so I'm just doing 4 just because of time. Okay, so I'm doing 4. So I've got 1, 2, 3, 4. Okay, 1, 2, 3, 4. You go like a squiggle, squiggle, put a pointer right there. You can stop right here at 14 and a half. Now, the way I taught you guys last week is any number that's on the boundary. Okay, now I'm calling it the boundary, or on a tick mark. Any raw data goes into the right-hand one no matter what. So if there was an 8.5 number in raw data, it would go over here, not to the left. What the author tends to do is say, okay, why do they set up the classes and the boundaries? If the classes are all whole numbers, so let's say they're whole numbers that the lowest whole number is 3 and the highest whole number is, say, 14. So the range is from 14 to 3. This is not telling you how many there. Oh, let's say this. Well, I can do this. F for frequency. Let's say there were 2 and 10 and 7 and 10. So if you add this all together, 29. Okay, that says there's 29 data values that are out there. Now there's 2 data values that are either 3, 4, or 5. You don't know which one they are. Just know that there's 2 of them. The author will then say, well, let's back this off so there's no, like if there's a number 5, it goes into the next, whatever the next one looks like. So what he does is says, let's back it off by a decimal place. So take a decimal place, split it in half. Basically halfway is in between here is 5.5. So that's why the 5.5 is there. So back this off by a half, so that's 2.5. So you keep the width the same. See, the width is still 3. And why 3? Because there's 3, 4, 5. There's 3 numbers. So the width is 3. The width is 3. The width is 3. The width is 3. So width equals 3. And then here it says 1, 2, 3. There's no issue if the raw, okay, I'll say raw data is from the number 3 all the way up to the number 14. So this is the minimum and this is the maximum. And there's a bunch of numbers in between, which would be 27 other numbers. And then of course you go, hey, this is 2 here, and this is like 10, and you know, and so on. This is 7, and this is 10. So the author's boundaries are like my creation of the classes with the tick marks. So if in fact I had 27 data values, excuse me, 29 data values, and the smallest was in fact 3, and the the biggest one was in fact 14. And remember I said all the numbers have to go in a spot, and your first one can't be empty and your last one can't be empty. And then you say, well, how many classes do you want, Jeff? I says, well, let's say it's 4. So don't you take the range and divide it by 4? That's the way I teach it. It's slightly different than the way author shows about it, because they use the word boundaries, and class is a little bit more formal. All I said is if you take the range, divide it by 4, and the range is 11, because it's 14 subtract 3 is 11. I get, let's see, that would be, goes into it twice with 3 left over. So that would be 2.75. And then you make a decision on what number. So most of you would probably say, oh, make that a 3. Make the width a 3. So then on mine, I would have done the following. Squiggle, squiggle. Start with the lowest, which is 3. And now you're going to say the width, we're going to choose 3 and see if it works, meaning that the last pile isn't empty, and there's 4 piles. So 3 plus 3 is 6, and then 9, and then 12, and then 15. And I have 1, 2, 3, 4 rectangles, and you put the raw data in, and if there was a tot, like a 6, if there was a raw data of a 6, it goes in this pile. So if over here, if there was a raw data of 6, it goes over here, because it's 6, 7, and 8 are numbers that go in the second pile. So there's some similarities but differences, and that's kind of, there was more differences for some of you in terms of the notation. I decided to let the construction of it go for those homework problems and let you do it this way of the construction of the histogram. So that's a 10-minute overview, Spencer, and maybe that helps. And if it's still confusing, then I would say just let it go. Know that the word class for me is piles or rectangles. Okay, I want 4 classes. That's what the author would say. Well, I want 1, 2, 3, 4 rectangles, 4 spots. Boundaries. I'm not going to ask you a specific number on boundaries or specific word or a question. I could ask you, what's the range? And you'd say, well, I don't know. I'd have to know the raw data. Okay, what if I gave you the raw data? Could I give you the range? Could I ask you the range? Yes. I could ask you what the width is. Based on this, what's the width? And you'd say it's 3, because it's 6 subtract 3, 9 subtract 3. What's the width over here? 3, 3. You just, so width, how many students? And you'd say, well, gosh, I just, without knowing the raw, I just count them up. 29. So that's the idea, Spencer.
All right, how did you know that the range was 11? Because that's not what I got when I tried to calculate.
Well, I said, what if the maximum number was 14?
Yeah.
And the smallest number was 3, so 14 minus 3
duh.
is
Right.
11. That's the range.
Okay, thank you.
Uh-huh. Okay, so no roll today, no roll. Okay, a little overview about chapter 3. You've got mean, median, mode. And then 3.2 was standard deviation and variance. Oh, and then also the range, standard deviation, variance, and range. There was formulas for that, but you don't need that. You just use your technology, your calculator. I said, like this one here, there's numbers, percentages. I said I'd go through it more detail. I'll do that at the end of class today because I'll take your exam results. I'll try to do this, take the exam results and show you a bell-shaped curve concept and explain to you, if I were to grade on a curve, what your letter grade would look like instead of what you think that your grade is. If you think that 90% is an A, you might be surprised that it might not. It might be a C because it's all dependent upon other students and how well or how poorly they do in your class. You're basing your grade on how you did against everybody else. So if I graded on a curve. So I'll show you what these numbers mean later on. And it leads us to the what's called measures of position. Right here, measures of position. And that's today. So, percentiles. You probably have heard this. Likely it's in, let's say, testing. SAT, a number of us have taken standardized testing scores, SATs, and you get back results, and it shows you, sometimes it's a bunch of gobbledygook, you don't understand it, but it shows you somewhere it says what percentile you are. Here's another place. My daughter-in-law just had her first child about a year ago plus, and in pregnancy and growth and everything else, they talk about what percentile is my grandson doing, and you're comparing it with other people, with other kids. Is he in the 12th percentile, 80th percentile, and what does that mean to a parent? And so that's what percentiles. I'm going to show you what that means mathematically, and then you can apply it to those two scenarios. The children's growth over time and also your SAT scores, because you're comparing your score against other people. So there'll be percentile. There's also going to be something about quartiles. You'll see this quartile 1, 2, and 3. Quartile 1 and 3 is in your calculator. It's in your calculator, and if you've been playing with your calculator some, you would have gone into stat, edit, and you would have had data in there, and eventually stat, calculate. And then if you scroll down, you'd see Q1, for instance. So Q1, oh, by the way, Q2 is median. It's the middle number. And so Q2, second quartile, is the same as median. It's also called the 50th percentile. In the 25th percentile, and 75th percentile, and so on. So I'll show you all about that today in percentiles, and let's see what else do we have to cover as well. Something about what's called Z-scores. It's your introduction to a Z-score that you'll see in chapter 6 and on. Chapter 5 has nothing to do with Z-scores. So you're going to get a brief introduction of what this is, and it's related to a bell-shaped curve, as you can see again. So we'll come back to that. And the last thing is creating what's called the box plot, a box and whisker plot. And I'll show you how to interpret this, where the numbers come from as well. And that wraps up that should be a 3.4. That's weird, 3.4. Typo, that happens. Yep, typo.
I'm sorry, do you mind going over how to find standard deviation again? I lost it in my notes.
Well, in your, the videos are there.
Okay.
Recorded videos in the cloud.
Okay.
So when you go to Canvas, you go under Tech Connect Zoom, and look under cloud recordings and you look for the date. It was brought to my attention by a student that they said, hey, Jeff, these dates, I think there's a problem with the recordings. It's only showing, it's weird, only showing me like looking around at stuff, not even saying anything. You got to look, I think it turns out to maybe the next day turns out to be the actual recording with all the video that you see like we're doing right now for an hour and a half. So look at the next day instead of the day of. It seems to be taking longer for that. Yeah, so you can find it there, and I'll be happy to stick around after class to kind of go over that with you as well afterwards.
Thank you.
Yeah. So let's see, 3.4, yeah, see there's more pictures that we're going to do. Okay, so let's get started on percentiles. A percentile gives the percentage of data that's less than or equal to a certain value. So what does that mean? Okay, you're taking SATs scores and you get a particular number. And in the past, it's been out of 800. I think it was 800, like for the math portion. It's out of 800. And to get a perfect score, I know one student in my lifetime, or one young person who's a friend of my son that got a perfect 800 on the math part. Well, these are almost like smarty pants. Gosh, they're probably going to end up getting admitted to MIT and Harvard and some others. That's the way it used to be. He did better than, sounds weird, than 100% of the other people. There were 100% or close, 99.999 of the people who did worse than him. That's where it says less than or equal to us. So if he got an 800, there was 100%. So he was at the 100th percentile. Let's say down here, you're going to see 75th percentile down here with the problem I'll do in a moment. That means whoever scored a certain value, whatever number of these, there would be 75% of all the data values are below this one score. Let's see, 2, 4, 6, 8, 10, 12. No. I think 75th is like quartile, isn't that? That's like 3/4 of a dollar. 3/4. So if I see 12 data values and I bust it up into fourths, then I look, and they have to be in order. That's the idea, is you're going to arrange them in order. Then there are 3/4 of the data values that did worse or did below whoever got that score that is represented by the 75th percentile. For instance, if I did this, just put this in order, and I'll show you how all this works too. So the lowest was here, 30, whatever this means. And I'll explain what this, I'll work backwards. 30, the next lowest number looks like maybe 44. Is there any 50s? No. 60s? Yes, that might be the next lowest one. 65 maybe.
You missed a 50.
Thank you very much. There's a 50, 56. Squeeze that in. Thank you. 68. 70s. Okay, the lowest 70 looks like a 75. A 78. And then the 80s looks like there's an 81, 85, 89, 94. Let's see, 2, 4, 6, 8, 10, 12. I think I got them all now. So if I busted it up into groups of 4, that's quarters. Excuse me, let's see, groups of 3. I said it wrong. Groups of 3. There are 4 groups of 3. So there's one group. There's a first group of 3, second group of 3, third group of 3, fourth group of 3. Somewhere in here, one of these two scores-ish is representative of what they call the 75th percentile. This is a number. This is one of the raw data. So one of these numbers, maybe it's in between too, because we'll have to see that in between things. Remember the median? Remember how to figure out the median if there's an even number of data values? You take the average of the two middles. So there might be something similar to that in today, in the percentiles. So that means, gosh, in here is 75%. There's 3/4. So there's some threshold, one of these numbers, probably that one or the average between those, is the 75th percentile. You go like this, P of 75 equals, it's either 81 or it's 85 or it's the average. And we'll go through on how to determine that. All right, so the first thing you do is you arrange in ascending order, which I did. Next, you're going to do some funny little calculation here. So if I said the 75th percentile, you're going to go little I, whatever that means, is equal to, okay, this is the percentage. So for instance, this is us, 75% times sample size, or yeah, sample size. And our sample size down here is 12. Mo, yeah, the Three Stooges. Okay, Mo, Larry, and Curly. Okay, Mo in this particular would like to go to graduate school at Knucklehead University. And he knows that the school only accepts those students who score in the 75th percentile. They'll take anybody who scores 75th and higher. They want people who score a particular number to accept them. Anything below that, they don't get to go to the university. Okay, so it turns out that Mo scored an 85. Oh, well, this is Mo's score, Mo. Well, you'd think he's going to the university. You'd think he would, because these guys are above him. They're definitely going. And the question is, does Mo get in or not? Does he get in or not? So then you take 75% of 12, and that's, I believe it's 9. Jeff, how do you know that? Because you go 75 divided by 100 is the same as 75%. Or do the decimal, 0.75. You can go 75 divided by 100. See, P right here is like 75 in this case. Oh, 0.75 times N, which is 12. Yeah, okay, so you get the number 9. So the answer to the question is not 9. P of 75 has yet to be figured out. It is not 9. It's not. What the 9's going to do, or whatever else they talk about right here, it helps you find the answer. It helps you find the answer. Now, before I show you that, we're going to read the little italicized information here. If the P, okay, what the heck is the P? Let's see. Is the particular, okay, where? So I said if, sorry. If I is an integer. Oh, now you have to go back to the concept of an integer. I'm going to show you something. All of you have to know, well, it's been a while, Math 150, beginning algebra. I do this with all my students, and I carry it through intermediate algebra if they take me. Number classification. The very first day, they are told, what the heck is an integer? So you guys need to know this too. Integers are counting numbers, negative and positive. So it says if I is an integer, oh, like the number 9 is an integer. It is. Like 0, 1, 2, 3. What isn't an integer? Fractions, decimals. Now it says if I is an integer, right here, whole number, no fraction, the 75th percentile, okay, or the 12th percentile, or okay, is the average, mean. That means you add up something between something. So there's two numbers. You're going to take the average of two numbers, kind of like the median. So here's the idea. If you get a nice number like this, you got to find two numbers. You're going to find the 9th number. See, I equals 9. You find the 9th number and the next one after that, which is the 10th number. I'm using this to help me count. The I is helping me count. Okay, where? Count to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the 9th number, and that's the 10th number. You take the 9th in this case and the 10th, and you come up with the average. That means you go 81 plus 85 all over 2. You get 83.5, and that is P of 75. That's the 75th percentile, is 83.5. It's not one of the raw datas in this case, but it's the threshold. They're going to let anybody who scores 83.5 or higher into the university, and Mo is in because he got an 85. The question is, find the 75th percentile, which I just did, and will Mo be accepted? And the answer is yes. Now in your calculator, if I put the raw data in your calculator, we know how to do that now, because last time we met, I showed you how. Spent a lot of time. We're going to go Stat. We're going to go Edit. We're going to go get rid of all that other junk that's in there. Toggle up, hit Clear, and hit Enter. And we're going to enter the raw data. It does not have to be in order. I'm just going to do the bold numbers right here, not my red ones. I'm going to enter the raw data in here. Okay, I've got 12 data values right there. And my instructions that I gave you in your packet is get out of it, second quit, clear home screen. Now we're going to start over again with the stat. Calculate. Oh yeah, 1 var stats. That's what Jeff's instructions have in the textbook as well. Enter through all that. Just hit enter all through that. If you've got the 84, 83, slightly different. We talked about that too if you were here last week. Okay, and then I get a bunch of numbers. X bar is defined to be the sample mean. Basically, it's just adding them all up and dividing by 12. Never going to use the second one, never going to use the third one, although you need to know what that symbol means. Yes, you know what that symbol means now. That's, by the way, is a little s, not a big S. You need to know what that symbol means and how to speak it. Okay, if I scroll down, then you notice Q3. See the Q3? Called the third quartile. That's exactly the same has the 75th percentile. Now you might say, why is it 83 and not 83.5? Well, I think I made a mistake. I think this is my mistake in here. I did the math wrong. I just did that in my head without doing it. If you add 81 plus 85 divided by 2, 81 plus 85 divided by 2, it's 83. So I made a careless mistake. It's 83. Well, now I know the calculator in my arithmetic, they're supposed to match up, and they do. Q3 is the same as percentile 75. Now, really easy to get the answers with the 25th, 50th, and the 75th percentile. But what if I asked you for the, I don't know, 63rd percentile? You won't get it from your stat calc. 63rd percentile is not there. You don't have all the percentiles. You just have the 25th percentile, the 50th, and the 75th. What about the 60th or 62nd, Jeff? You have to do it by hand. You have to. So going back to this again here. Okay, so if it turns out to be a nice, sometimes you can use the word whole number. That'll work. So your whole number, that'll work. Then you got to do this little extra work, which is taking the average of two numbers. If it's not an integer, okay, let's do the same one and let's ask the question, find P of 60, meaning 60th percentile. So I'm going to find the I first. I'm looking for this answer. And I'll go 60% times 12. And I'm getting 7.2. Now that's not an integer and that's not a whole number. So it says here, if you don't get that, you always round up. Jeff, hold it. Wouldn't I round down? No, the rule is round up. Forget the rounding rules in general. Just make it the next one up. Just make it the next. The number 8, the 8th position number. The 8th value, the 8th number. Okay, I'll go back over here. The 8th. 1, 2, 3, 4, 5, 6, 7, 8. 78 would be considered P of 60. The 60th percentile is 78. The score 78 represents that. That means about 60% of all the data, 60% is about this many. 60%. Well, 1, 2, 3, 4, 5, 6, 7. 7 out of 12 should be close to 60%. 7 out of 12 is close to 60%. Yep. So that's how percentile, at least initially, calculates out. If I did it on a large set of data, is it in order? The answer is yes, because remember this is the home run people here, guys. Smaller to larger, and if I want to find the 80th percentile, you want to find the home run number that is better than 80% of all the other data values. There was only 20% that did better than them. That's what it's saying. So P of 80 equals, and waiting for the answer, and you go here, I equals P over 100 times N. Okay, I equals 80 over 100 times, I think there were 49. Oh yeah, 49. They're up here. Oh, of course, it's 0.8. I mean, 80% is 0.8 rather than doing them by the fraction, of course. Times 49. Okay, I get a number, 39.2. So you go up to the next one, which is 40. And now you count. The answer, I still don't know the answer yet until I've counted over 40 numbers. Okay, here, start low to high. 1, 2, 3, 4, 5, 6, 7. 14, add another 7, add another 7. 21, add another 7 of this. Okay, 28. 35. Okay, here we go. 36, 37, 38, 39, 40. Whichever baseball player hit back as of 2015 hit 583 home runs, that's the baseball player that did better than 80% of his peers. The number here would be 583. That's how that works. Okay, I've talked about these already for you. I showed you where to find them. You know how to find them. Now, these come right out of a calculator. That would probably be the easiest way. To me, if you put it all on your data, all the data in your calculator, and then do one var stat, if this was being asked on the exam, put your data in the calculator instead of doing this thing by hand, by hand, instead of doing this thing here. Just put the raw data in your calculator and look for Q1 and Q3. Comes right out of your calculator. Okay, that's percentile. Now, z-scores is another way of measuring position. Z-score. So we're back to this bell-shaped curve. Number right here in the middle is called the mean. And don't forget, it's also the median and it's also the mode because it's called symmetric. Okay. So for you guys, when the bell curve so you place a marker in the center, which equals the mean. Then place 3 markers to the right. So if I were going to do it like here, okay, I think I might have talked about this. If I didn't, I'm telling you right now. The reason why I left a gap right here will be probably, well, it will be explained more in chapter 6. Just don't make it connect. Jeff, what about this? Well, if I took a magnifying glass and a microscope or whatever, really looked, it never connects. It just looks like it does. So I took this image off the computer. When you draw it, it never connects. So leave the gap. See, it kind of like goes like this. It gets closer and closer, never connects. And then it says in the center, right here, put a marker, and that's the mean. So sometimes we call the mean mu. Remember that? The definition of mu, definition, is population mean, population average. And sometimes I'll say or, it could be X bar, and X bar is the sample mean or sample average. And you might say, Jeff, which one do I use? Well, it depends on the nature of the problem. When I say it depends, if they'll have to explain to you if it's the entire population, they have to tell you that. And if it is the entire population, you'd use that symbol. If they don't, here's a rule of thumb. If they don't tell you that it's everything, then you always assume that it's just a sample. And therefore, I would just use the X bar as a representation. Now, I'm just going to use the word mean here rather than mu and or X bar for the time being. The next thing says also 3 markers to the left. Okay, 3 markers to the left. So I go over here and I go 1, 2, 3, and 1, 2, 3. So 3 markers to the right, 3 markers to the left. Always. You see the distance between each marker? I'm trying to make it where it's the same. So call it the width. So the width is always the same. They call that a standard deviation. The standard deviation is like the width of a bar. The distance from 500 to 600 is called a standard deviation. There it is, it's 100. So it acts like the width, W for the width. And you can look at this, says, and the author says the same thing. 600 is 1 standard deviation above or higher than the mean, and 400 is a standard deviation below. Okay, how many hundreds is 700 above? How many hundreds? 2. So the representation is 700 is positive 2 standard deviations, and 300 is negative 2 standard deviations. This would be like the number negative 2 right there. This would be positive 3. That's a positive 1. And when you flip the page, that's exactly what this formula is kind of indicating to you. This formula will calculate a number, and the number will be either, well, it'll be either like number 0, or it's going to be positive or negative, anywhere usually between -3 and 3. Usually. I mean, sometimes if it calculates anything further than that, then it's what we call an outlier. It's like extreme, unusual. So if I went over here and said, okay, if I use that formula like this, and X bar minus, I think it's X minus X bar. Yeah, it's X minus X bar, or X minus mu. So let's say this is the mean, this is X bar, and this is not the width, it's going to be called little s. And if you put it in here and you go, all right, what's this number going to get me if I put in X is the raw data? This is raw data, or a particular data value. So if this is my X right here, that's my X, then I put 600 right here, minus X bar is 500, little s is 100, So what they say, it's a z-score. The z-score is the number one. And it tells you, because it's positive, the marker right here, this raw data, is a number one in comparison to the mean. It's a number one. And more about what these numbers represent in chapter 6. All you're doing is using the formula. That's all you're doing right now. Just plug and chug, plug and chug.
I'm sorry, Jeff, I'm confused. What's the number one? What you were saying, is this 700?
No, the Z on the previous page was the number one.
Oh,
So this is a middle number right there. The Z being a number one is the first tick mark in blue, where the other ones, that's the second and that's the third. This is the first, second, and third to the left of that. So if you can see this in blue right here, I'll do kind of a squiggly. That represents, that's a number one somehow. The position, think of it, it's the position of the number 600. 600 sits one width away from the middle. The number one is like the width. The number 800 sits, it turns out to be 3 widths from the middle. 3, and that would be the z-score equals 3. The z equals 3. And then down here it
So
says,
picture it as a number line, and whatever the mean is the zero of that number line.
yes, yes.
And then you're counting widths or bins or.
3. This is -3. Good. You're sort of on the right track. And later on, we'll find out how these all work again in chapter 6. So it's like redrawing the picture on a number line. Zeros in the middle, 1, 2, 3s here, -1, -2, -3. So instead of this being 800, it's the number 3. Instead of this being 600, it's the number 1. And anything beyond, okay, so 1, 2, okay, these are SAT scores. This is like the number 300. For someone to get an SAT score of like 200 or lower, that is like really unusual. The person is either, I hate to say this, stupid. They don't know anything. They didn't learn anything in their math. Or they just didn't care and they just didn't mark anything, right? And then for anybody to be beyond 800, well, that's impossible, first of all. 800 is perfect. But it's called an outlier. Let's see, where do we call it? Further beyond is unusual. So beyond 2, it's unusual. Outliers are way out here beyond -3 and +3. Between -2 and 2, between here and there, this is, we call it usual, usual, whatever that means, and you'll find out later on in the course. Between here and here is kind of unusual, and right there on the end would be ridiculously unusual. Like we call it outlier. Like it's almost impossible. Outlier, way out here. Unusual is right there. So for us, if you go over here, unusual would be in here. For someone to score between 700 and 800, that's kind of unusual. I mean, they're really smart. Just for someone to score between 200 and 300, that's kind of unusual. That's weird on the other side. And for someone to score below that, says, oh my gosh, well, that's like, what were they thinking or not even doing? That's an outlier. Looking at the time, I got to kind of skim through this. Okay, I think the big thing about the box and whisker And this will be true for the group quiz. Because I'm not going to ask you to build it, I'm just going to ask you to interpret it because of time. So anything on the homework, if it says create or build a box and whisker, ignore that. Just see if you can answer questions based on the box and whisker, and that's what I'm going to take a couple minutes to show you, and then I'm done for today. Interquartile range is pretty easy. It comes from the calculator. That's a symbol. Interquartile range comes from your packet in the back. It's the difference between Q3 and Q1, and you get that from your calculator. That's easy. Let's see. Over here, information about the 5-number summary. It just turns out it's the last 5 numbers in your calculator. It's the last 5 numbers. It's the minimum, it's Q1, median, Q3, and the maximum. Comes right out of your calculator and it gives it to you. And then in terms of, don't do this because we don't have time. We don't have time. Don't do it. I can demonstrate this to you quickly on what this is called a box and whisker. You guys know what this means. What this is called a histogram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 bars. Yeah, between 5 and 20. Yes, good. Okay. This is called a box and whisker. The median, excuse me, the median is sitting right there. Q1 sits right there on the number line. Q3 sits right there on the number line. There's a number line down here on the bottom. This is typically what's called the maximum, and this is called the minimum. And that's how you create your, these are the whiskers. This is symmetric. Here, symmetric. They call it normal, and more about that in chapter 6. That's called symmetric. This is called skewed. What tail skewed, by the way, for you guys?
Right?
Correct. This is right tail. Right tail skewed. Notice how the whisker is pulled farther to the right if it's a right tail skewed. It's like, see the middle right there? When you pull on this, everything slides this way. So the box even stretches out and the middle number goes farther to the left. See, it's pulled. And the other one is, well, there's another one that's left tail skewed. I don't show that. These are called outliers. Those are outliers. It looks like there's 5 outliers. It's beyond some number they've decided. And don't worry. Well, how do you know how far to put the whisker right here? Don't worry about it. Just know that any of the dots that are outside the last whisker thing, they're called outliers for you guys right now. And how do you describe this here again? It's the same thing. How do you describe this?
Median.
Yep, MED. This is still Q1. This is still Q2 right there. This is still minimum. Well, now that whisker is not the maximum. The maximum is the last dot right here. This is the maximum. Is the last dot. It's the biggest number on the number line. And then that's it. Okay. Well, a lot going on. We had a lot of our time, and it was okay to have Professor Casas here to explain that, and I'm okay with spending some time like that. Let me get you started, show you what you're looking at, put you in groups, and then we're done for today. Sorry it's a little longer class today.
One last question.
Yes.
Our answers for the group quiz is a piece of paper that we're taking a picture of and sending to you, or is it something on Canvas we're filling out?
I'll go over that tomorrow. Not
For the
tomorrow,
quiz,
but,
for the quiz we're about to take?
no, this is the baby quiz. It's not a group quiz. This is just like you did on the first one, where you're going to take it through Canvas. It's multiple choice, true, false. Multiple choice, true, false. You're going to click your answers in when you're ready to take the quiz. Let's see. Go here. Go here. Go here. Here. Let's see if this is right. This is you guys here. Pretty sure this is Monday, Wednesday. Yeah. Assignment, you'll find it under assignments. Okay, no, not that one. Daily quiz. Okay, so daily quiz number 2. Okay, now it's a PDF. I'm going to open it. Publish.
Hey, Jeff, we're not seeing that. We're
Yeah,
seeing
we're only seeing your
Craftsman
house
Ranch.
plans.
Okay, hold on a second here. House plans? Are you serious? That was weird.
Well, you're
That-
looking for a house for a dog. I see
Yeah.
that.
Yeah. Okay, let's try this again. Let's try this again. Let's try this. That was funny. Do you see that now?
Yes.
Yeah.
All right. So daily quiz number 2, you're going to open the PDF. This one here, you open the PDF. You open it like that, and you'll see probably 5. Let's see if there's 5. 1, 2, 3, 4, 5. Yeah, 5 questions. That's it. And your answers are going to be put in here. So when you do your preview, well, me, it's a preview. I think you, it's going to say, take the test. You're going to put your answers in here like a little Scantron sheet. And then when you're done, don't forget, submit the quiz. Now, Claire, you open up your PDF. You should be able to do that right now. And I'm going to put you in groups. Right now, I'm going to get out of this thing. And I think just because of sake of time, I'll put you with maybe an extra, I'll put you in groups of 3 instead of 2. Let's see, 3 to 4, 2 to 3. Okay, so let's do 3 to 4. There'll be 1 or 2 groups of 4. I usually don't like to do bigger, but I'm wondering if that's helpful for, there's only 1 group of 4. The rest of it's group of 3. Okay, I think that'll do. So here you go, and I'll be outside the main room if you need me.
I didn't get the option to join a group.
Say it again, Uzel.
I didn't get the option to join a group.
Okay, I see you right here. I'm gonna, let's see if I can get you, I'll move you to another one. Let's see if that works better.
Okay.
How about that now?
I don't see anything.
You still don't see it. Okay. I just moved you there. That's weird. Elizabeth, are you there?
Oh, now I do.
Yeah, I'm still here.
Okay. There you go. Did you see your invite?
Yes.
Looks like you're in group 1.
Okay. Just to touch base with you really quick, I'll be ready for our first quiz on Wednesday. I kind of decided that I'm probably just going to try to study, getting caught up on everything. And I'm definitely going to be using the tutoring center, which I'm very happy about.
Yep.
2 things, the homework, when is all the homework due?
The day of the
Again.
exam. The day of the
Okay.
exam.
Okay, and then I got the workbook, but I didn't get the book for like the book that you said we wouldn't have to pay for. I didn't see it in like the email links or anything.
Oh, right after you're done with the quiz, I'll be
Mhm.
out here. See me, and I'll email it you directly.
Okay. All right. Thank you.
Okay.
Okay.
Hi guys. Someone calling me? Is Lillian calling me? Oh, well, there you are. Okay, yeah, I heard a voice. Yeah, they're still working on a quiz, probably about 15, 20 minutes. Oh, we gotta fill it out. Oh, we gotta, yeah, I'll suck that out. And I was going to, load your, no, pose. I want to pose it now. So if I do it today, I can do that today. Smells smoky. So I wonder if I should do it tomorrow. No, I've got that block at time. So. Of course.
Sprinklers are all closed, but my, sprinkler system's all closed.
Oh.
And I tried the hose off the back of the house, and my bathroom.
Yeah.
It's probably pretty common.
Yeah, it's because there's some filter on that. So I'll take a look at, probably today, I'll do the faucets and not the blowing. And tomorrow, or sprinkling, whatever, because I'll need a hose anyway. And then tomorrow, I'll get the hose fixed and then hose off the patio. So about 15 minutes, I'll be done here, and then I'll start with the wash machine.
Yeah.
Well, how long are they gonna be? Are they just started, or they've been here for a while? So I can work on it, as long as they're done with the, right? Okay. Sounds good. Do you see a cell phone? I don't want to step on your, it's black. Yeah, that'd be great. Thank you.